Hello everyone, I hope you are all in good condition and healthy. Still with me Party Roseate. In this session I will explain how to optimize the operation of a kiln with a capacity of 5,500 tons of clinker per day. In the previous video session, we explained how to start the kiln operation, but the quality and capacity have not yet reached optimal. Let's continue to optimize the kiln operation, and operate the coal mill simultaneously with only one monitor display. The current kiln operating conditions, the temperature at the top of the preheater is 328 degrees Celsius, the kiln feed is 360 tons per hour, free lime is still 3.4%, decarbonization is above 91%, and heat consumption is still 3,740 kilojoules per kilogram of clinker. We have to improve the kiln operation until it reaches optimal operation. We optimize the kiln operation by increasing the fuel consumption in the main burner from 13.5 tons per hour to 14 tons per hour. Then we observe O2 in the inlet kiln. If O2 goes down and CO goes up, we can add air from the cooler or increase the ID fan preheater speed. What happened at the coal mill? Let's look at the display on the coal mill. There is an alarm. The mill vibration is high. This is because the low bed material causes the vibration to increase. We must try to reduce the mill vibration as soon as possible, so that the mill does not stop. We observe the process. The mill outlet temperature is still high. Try to keep the temperature below 75 degrees Celsius or around 70 degrees Celsius. The vibration is still above 7. The mill feed is 40 tons per hour. We increase the mill feed by about 2 tons per hour, so that the mill outlet temperature decreases and the vibration also decreases. We observe the process. The mill outlet temperature drops and the mill vibration also drops. Mill vibration is kept below 4 mm per second. We increase again 1 ton of mill feed, so that the vibration is lower than 4 mm per second. There is an alarm in the kiln system. We go to the kiln display. What happened to the kiln operation? There is an alarm at the inlet of the kiln, because there was CO up, after we reset everything back to normal. Then we observe that the free lime is still high at 2.9%, and the temperature of the sintering zone is still high at 1,494 degrees Celsius, and the O2 in the kiln inlet is 1.4%, and we see that the decarbonization is still well above 90%. We increase the ID fan preheater speed by 5% each, so that O2 increases and we can add fuel to the main burner. Then we increase the fuel consumption in the main burner to 14.5 tons per hour. We optimize the operation of the kiln and coal mill, which currently we use 18 tons of fuel in the calciner per hour, and in the main burner 14.5 tons per hour or 15 tons later, or a total of around 33 tons per hour. Then we look at the production capacity of pulverized coal in the coal mill, which must be adjusted to the fuel consumption in the kiln system. Here the pulverized coal product is 38 tons per hour with mill feed 43 tons per hour. Because here the mill outlet temperature is still 77 degrees Celsius, we increase the mill feed by 1 ton to 44 tons per hour, because the stock of pulverized coal in the bin is still low. We are back again to the display monitor kiln. If it is seen that the secondary temperature is still below 800 degrees Celsius, and the free lime is still 2.8%, the kiln speed is 3.0 rpm, and the sintering zone temperature is still quite high, we will increase the fuel consumption in the main burner to 15 tons per hour. The total fuel consumption for this kiln operation is 33 tons per hour. Then the heat consumption is still above 3,800 kilojoules per kilogram of clinker. It is hoped that the addition of this fuel will reduce the free lime and increase the kiln feed. We increased the kiln speed from 3.0 rpm to 3.2 rpm. It is hoped that the kiln load will be reduced, and we can get clinker quality according to the free lime standard of 0.8% to 1.5%. O2 in the kiln inlet is below 1%, we can add O2 from the cooling air. We add cooling air, especially to the cooling air in grate 1, each cooling air we increase 10% to 90%. Total cooling air consumption is still low at 1.7, the standard is 1.8 to 2.0 normal cubic meters per kilogram of clinker. We increased the use of cooling air from grate 2, each cooling fan we increased to 90%. Now the total use of cooling air is still 1.8, this is still not enough, we can see that the clinker temperature is still above 150 degrees Celsius. We add cooling air consumption from grate 3, each cooling fan we increase to 90% as well. The total cooling air consumption is 1.9 normal cubic meters per kilogram of clinker. We return to the kiln display monitor, we have to reset a lot of alarms, because we made changes to the cooling system, the kiln hood draft is close to positive. Then 95% decarbonization, but the free lime is still 2.5%, we observe all the operating parameters of the kiln, the temperature in the calciner is still quite high at 890 degrees Celsius, and the decarbonization is still 94%, we increase the kiln feed again to 190 tons per hour each, or a total kiln feed of 380 tons per hour. We increase the speed of the ID fan preheater again to 100%, so that the temperature of the uppermost preheater can rise a little. Let's look at the operating parameters of the cooling system. Currently the kiln feed is 380 tons per hour, the air pressure for the room 1 is 96 millibars and the speed grate 1 is 50%. The air pressure in room 2 is 64 millibars. With the use of air for grate 1 alone is 1.17 normal cubic meters per kilogram of clinker. Because the speed grate 8 was increased earlier, the clinker on the apron conveyor has increased slightly, and now it is normal and the temperature is also normal. We look at the kiln operation control parameters, here we see the O2 inlet kiln is sometimes below 1%, and CO rises. Free lime 1.6%, and kiln feed 380 tons per hour, the highest preheater temperature is 324 degrees Celsius, because the ID fan preheater speed is already 100%. Then to add O2 we can add cooling air. We add air from the cooling fan from grate 1, we increase each by 5% for the cooling fan grate 1. Then for the grate 2 cooling fan, we also increase each 5% to 95%. Total cooling air is 2.1 normal cubic meters per kilogram of clinker. We return to the main display of the kiln monitor. O2 inlet kiln is still 1%, and free lime is still 1.6%. We increased the kiln speed from 3.2 rpm to 3.4 rpm, so that the kiln load is reduced. We see in the coal mill it's yellow, the mill outlet temperature is 76 degrees Celsius, and the vibration is still 4.8 because the bed material is low. We increased the mill feed from 44 to 45 tons per hour. With a hydraulic pressure of 80 bar and a mill feed of 45 tons per hour, the product becomes 39 tons per hour. We observe the stock of pulverized coal in the bin, which is for the calciner burner 30 tons and the one for the main burner 49 tons. Back to the kiln monitor display again. With the addition of the kiln speed earlier, we are trying to increase the capacity. We increased the kiln feed each from 190 tons to 195 tons per hour, or a total of 390 tons per hour. The free lime is up to standard, it's already 1.4%. But here the O2 is low and the CO at the kiln inlet rises. We try to increase the speed of the ID fan kiln filter a little, so that a little more O2 is added to the top preheater and at the kiln inlet. We expect all kiln operating parameters to be normal, all groups are green or no alarm. Now the O2 in the kiln inlet is above 1%, then the free lime is 1.4%, and for decarbonization, it is still above 90%, and the heat consumption also drops below 3,600 kilojoules per kilogram of clinker. In this session, to optimize kiln operations and coal mill operations, the kiln feed is 390 tons per hour, that means a clinker production capacity of 5,500 tons per day can be achieved, and free lime is still in accordance with quality standards. Then the operating parameters of the kiln and coal mill are all under control, meaning there is no alarm. Alright, for this session we will finish here first, then in the next session we will explain how to operate the raw mill, kiln and coal mill, which is operated by one operator, using one monitor display. Thank you for watching this video. I hope it's useful, and don't forget to subscribe, like and comment, and share it with friends who need it. See you in the next video.